All right, so apologies to everyone. Yesterday, I forgot to record the meeting at the beginning of the meeting. So we don't have a recording of yesterday's lesson. However, I gave the same lesson or approximately the same lesson last year. So if you want to review the lesson we had yesterday, you can go to last year's curriculum and we have a recording of me giving the lecture last year. It was pretty much the same lecture. I just was at home instead of doing it remotely instead of here. So, oh, we got a few more people. So we're just starting. I was just letting everyone know that I forgot to record the recording yesterday. So if you want to review it, you can watch last year's lecture on the website. Okay, also for the people here in person, I realize we have a kind of small group in the Intro to Python in person here, but we have some extension cords. If you can't reach your laptop to a power outlet up here, feel free to come grab them. Okay, so we're going to just continue exactly where we left off yesterday. And I actually accidentally deleted the notebook I was using, but that's okay. It was just kind of a scratch notebook. So I'm going to make a new one over here in the launcher. I'm going to go to create a new notebook. And yesterday we talked about several things. We talked about what variables were. We talked about a few different types, including integers and floats. We talked about strings. And then we talked a bit about containers, mostly about lists and tuples. So I want to pick up there. We talked about, just a quick review, we talked about what a list was, where we can have lists of numbers, for example, like this, how we can access them using this bracket notation, where we say a list bracket 0 for the first element, because Python starts indexing at 0. And obviously 1 would be the second element. And we talked about how tuples were just like lists, except they used parentheses instead of square brackets. And unlike lists, they couldn't be modified after you'd created them, but otherwise they were very similar. So before we move on to control flow, which is what we're going to talk about most of today, I want to start by just continuing with these containers and introduce just a couple more containers. So the first kind of container I want to introduce today is called a dictionary. And dictionaries are containers that I use pretty much every day when I'm programming. They're one of the most useful containers in Python. So just as an example, I'm going to make a dictionary called fruit prices. So the idea behind a dictionary is it's sort of like a list, where a list is a collection of items, and each item is assigned an index number, like index 0 or index 1. So in our example here, 10 is the item with index 0, and a string here is the item with index 1.
Noah,
in a dictionary, yeah?
could you share your screen?
Oh, I'm
right
sorry.
now we can just see you.
Sorry, thank you for reminding me.
Mhm.
There we go. You can see my notebook, right?
Yeah, thank you.
Yeah, thanks for the reminder. Okay. All right, so a dictionary is a lot like a list in that it's a collection of items, but instead of being assigned to integer indices, they're assigned to any object you would like. So to get a sense of what that's like, we'll just go ahead and make this example. So for a dictionary, unlike a list, which uses square brackets, we use curly brackets. Oops. There we go. And the way we write entries in a dictionary is we put what's called the key. So here's a key, which is apple. And then we put a colon, and then we put what's called the value. So here I'm going to say apples are 65 cents. And then we can separate items with a comma, just like with a list. So our second entry is going to be mango. And mangoes are a little more expensive. And then strawberry. And here so far, I've had apple and string and strawberry, apple and mango and strawberry be strings. And these two are floating point numbers, these values. But a dictionary doesn't have to use all the same types. So we can, for example, now put a string here. We can say these are $3 per pound. We can say durian is unavailable. And I'm just going to put one more entry here just to make a point, basically. Your keys don't have to be strings either. So I can put 5 and say, just to make a point. And then I put a close bracket to end the dictionary. going to go ahead and evaluate that with Shift Enter there. And just as a reminder, whenever we assign something, there's no, it doesn't evaluate anything. So that's why this cell doesn't print anything out. But let's go ahead and see what the interpreter prints out if we have it evaluate fruit prices now. So pretty much the exact same thing we just entered. This is the kind of canonical way to enter a dictionary in Python with these brackets and these colons. It's not the only way, but it's the way we'll use for now. Now, okay, suppose we want to look up an entry. Suppose we want to know this. Well, with a list, we saw up here how we use this kind of notation where we say a list, and then we use square brackets with a 0. And with a dictionary, it's very similar. So what we can do is say fruit prices, and then we put a square bracket, and instead of an integer index, we put the key that we want to look up. So I'm going to look up mango. So this is just like if fruit prices were a list, except we put the key instead of the integer index. And it gives us back 1.5, which is the value that is mapped to mango. Similarly, because we have a key here, the key is the value 5, we can look up fruit prices 5 exactly the same way. And we get back the string mapped to 5, which is just to make a point. However, dictionaries aren't lists. You can't access them by integer generally. Here we can access the integer 5 because we have a key that's 5. But if we asked for fruit prices 0, we get a key error. So this is another error. This is, I think, the second or third error we've seen. Basically, this is a key error, and it basically just means that key wasn't in the dictionary, so I didn't know what to give you back. If you're not sure if a key is in a dictionary, if you have a dictionary and you're not sure if a key is in the dictionary and you don't want it to crash, you can do a few things. First of all, we could ask the question, is 0 in fruit prices? And if we evaluate this, it's going to say false because 0 is not in fruit prices. Similarly, we can say 0 not in fruit prices, and that'll be true. And of course, if we ask something like apple in fruit prices, that is true because apple is also a key in our fruit prices dictionary. Here. Any questions on that so far? Yeah. Mm-hmm. Mm-hmm. So you mean if I had like 0 in fruit prices and then I also had 0 not in fruit prices? Yeah. So okay. So for everyone on Zoom, the question was, what happens if you have multiple of these kinds of lines in a block? What happens? So what Jupyter will do is it will evaluate this whole thing as a block of Python code all at once. But when Python evaluates this, it looks at the first line and it runs it as an independent line. And then it looks at the second line and it runs it as an independent line. And then it prints out whatever the last line in the cell evaluates to. Yeah, so that's why we get false. Well, actually, that's why we get true here, because this evaluates to false, but it's not the last line, so it doesn't matter. Just as an example, just to kind of demonstrate that this works, I could say first question equals 0 in fruit prices, and then I can evaluate 0 not in fruit prices, and this will be true. But now, if I ask what first question is, that'll be false because it did run this and assign the result. It did run this line and assign the result to first question, the variable. Does that make sense? Okay. Correct. Yeah. Yeah. Just to see this dictionary or this up here. Mm-hmm. Any other questions? Okay. Similarly, we saw that with a list, you can assign things. So for example, if I scroll back up to this list we made, we can say something like list 0 equals 0. And then when we ask for a list, we'll see that the first element has been assigned to a 0. You can do that with lists, but not with tuples, is what we learned yesterday. And dictionaries, like lists, are mutable, which means we can make assignments. So for example, if we want to add a new price, we can say, whoops, banana. The price of a banana is $10. Whoop, I misspelled fruit prices there. And now, when we look at fruit prices, we see that there's also an entry for banana. Similarly, we can overwrite an entry. So bananas don't really cost $10. So we can say reset that to banana is just $1. And that works just fine as well. Now, an interesting thing about dictionaries is you can do a line like this where banana wasn't already in the dictionary. You can't do that with lists because lists need to be kind of in an order. And so you can append to a list, which we saw yesterday, but you can't assign to an element that doesn't exist yet. So if your list is only 4 elements long, you can't set element 6 or element 5, but you can append the last another element to the end. Okay. Any questions so far? All right. Oh yeah, go ahead. If you want to add 2 values to a single key, is that what you asked? So yeah, so if you want to have 2 values for a single key, you can put a tuple as the value, for example, or a list as the value. So for example, I could say fruit prices of a banana is 10.1. You can do that, and all that does is then it just makes the value of banana a tuple. You can do that, but you can't have 2 keys that are you can only have 1 of each key in the dictionary. Yeah. Now there are special kinds of dictionaries called multi-maps and some other things. There are other data structures that allow you to have duplicate keys, but they're generally not very useful. They're kind of sometimes useful in very specific situations, but they're not useful enough that we typically cover up. One more type of data structure I'm just going to mention really briefly because honestly, I use dictionaries and lists every day when I'm programming and tuples, but sets are the final kind of data structure that's kind of core to Python. Every once in a while I'll find a use for a set, but they're just not as useful. So we're just going to cover them very quickly. A set is basically like a list. So here's a set of numbers. To make a set, you just write set. And then set is basically a function, and what the set function does is turn a list into a set. So we pass this set function a list. So I'm going to just say 1, 10, 15, 20. And then I'm going to put a duplicate number here. So like I'm going to put 20 again and then 1 again. And what this will do is create a set of these numbers. But since it's a set, whoops, I didn't really spell that right, but that's okay, a set numbers. Since it's a set, it will remove all the duplicates. The main purpose of a set is you can ask questions like, is a number in a set? So 10 in a, and you can figure out whether you've tracked something. The main use for a set is if you're trying to keep track of things that you've looked at and you want to be able to check if you've looked at something already. Honestly, I don't use them a whole lot in practice, but I just wanted to make sure you were aware that they were in Python in case you needed them at some point in the future. Okay. Any questions about any of that before we move on and talk about objects a little bit and then move on to control flow? Yeah. Yeah, so An example might be if you were trying to represent the bids data structure. So are you familiar with bids? No? Okay, sorry. Oh, bids, yeah. Yeah, okay, so bids. So in bids, what you often have is something like a subject and a session and a run or something like that. You have these particular variables, and well, actually, sorry, this isn't a very good example. Typically, I only use them for really low level stuff, I have to admit. A lot of times what happens is you have a bunch of data and you need to process all of it in some way. You have some analysis you want to run on all of it. And you've got some programs that are running things, and you'll have a set of the stuff you've finished. And before you start another program, it will say, is the thing that I'm about to run in the set already? It's not a very good example. I'll try to think of a better one. But like I said, they're just not as very often very useful in day-to-day programming. Okay, so we mentioned briefly yesterday when we were looking at strings, how we could say here's a string and it's equal to, I think we said Madagascar yesterday. And then we did some what were called methods, like a string.upper to make that string uppercase. And of course, notice that this doesn't actually change a string, the variable. It just evaluates to an uppercase version of the variable. This is called dot notation. And the idea here is that whatever's on the left is what's called an object. And everything in Python is an object, actually. So strings are objects, integers are objects, functions are objects. Everything in Python is an object. And if you put this dot, what you're telling Python is that you want to run a method on the object. And methods are basically functions that interact with the object in some way. So this uppercase method, this upper method, is attached to string types, to anything that's a string. And you can call this method on any string. So this doesn't have to be a variable, in fact. We can say ABC dot upper. And since this string is an object in Python, it's a string object, that uppercase function method will work. So almost, in fact, like I said, everything in Python is an object. And so every object has some amount of methods on it. And for the most part, we interact with them kind of seamlessly. It's anytime we do something like, for example, assign one of the elements in a dictionary, what's actually happening under the hood is Python is calling some method on the dictionary that lets the dictionary update itself. But we use this syntax because Python has rather than forcing us to call something like set item on the fruit dictionary, we can use this syntax. Just to demonstrate that, we can say fruit prices dot underscore underscore set item and set banana to 20. And that will change banana, just like we had called, just like if we had called this as like this. So this line here with this weird underscore underscore set item underscore underscore method is actually the same as this line. Python just sees this line and says, oh, I know what you mean there. You mean you want to call the set item method. So this is just to kind of demonstrate that the way Python thinks about objects in general is that any piece of data in Python is an object, and objects are collections of methods as well as some bit of data. Any questions so far? Yeah. Yeah, so that's a great question. So for people on Zoom, the question was, is there a way to see all the variables that are currently active? So a lot of advanced IDEs, like if you use VS Code, I think they'll have a way to see what variables are currently running or currently active. In Python, because it's an interpreted language, you can actually just ask Python what the variables currently are. And to do that, we can use a function called locals. for local. That's short for local variables. And this is actually going to give us back a dictionary because the keys are the variable names and the values are their values. So here, notice we just set fruit prices. Sorry, this is a weird. So you notice there's a bunch of stuff that starts with 2 underscores in this dictionary. These are sort of variables that Python uses to keep track of things internally. So we don't really have to worry about them very much. So we'll skip over all these underscore ones, including this great big list of stuff, which I think is our history. And if we go down far enough, we'll get to the variables we've been using. Well, it's in here somewhere. So this is the history variable. Well, I'm having trouble finding it because this is so long. So rather than try to search through and find it, I'm just going to say loc equals locals. So let's capture that dictionary. And then let's see if fruit prices is in it. And it is. And in fact, if we ask for, if we ask for the fruit prices variable from the locals, the dictionary of locals, we'll see that we get the exact same dictionary back that we have defined. So obviously this is a little bit of a messy way to see all the locals because it's got all this kind of internal Python data inside of it. But if you just want to know if a particular variable is defined, you can pretty easily use something like this. Yeah. If what you're looking for is like a tab that lists all the variables and their current values the way that like MATLAB does, I don't think Jupyter has that built in. I do think there are extensions you can install to Jupyter that will do that for you, but we don't have them installed on the hub. Okay, yeah. With the set item? Oh yeah, let me go back up and show that to you because that's because that's sort of a Python kind of internal method. They use double underscores on either side, so there's 2 underscores there. Yeah, no problem. I don't recommend ever using this syntax to set an item. This is just kind of difficult to read and a little obfuscated. This syntax makes sense to everyone, and so I wouldn't recommend actually using this. I just wanted to demonstrate that they're kind of equivalent. Okay. Any other questions before I go on? Yeah. All of the, say again? And it stopped producing output? Oh, I would try reloading it because every once in a while there's a weird bug in Jupyter Hub. If it still does that, then let's look at it. Someone raised their hand on Zoom. Do you want to ask a question?
Yeah, quick question. What's the difference between assigning locals to a variable as opposed to just doing locals with the parentheses and looking for fruit prices?
You mean like this? There really isn't any difference. I was just kind of making it explicit what I was doing there. So this, oh, whoops, I misspelled that. But yeah, this is basically the same as first running this and then running this. And the reason is because here we run locals and we assign the result to loc. So we save that dictionary and then we look up fruit prices in the dictionary. Here, we don't save it to loc, but we run locals. Locals evaluates to that dictionary. And then we basically say, look up fruit prices in that dictionary. So we could also have put parentheses here if that makes it a little more clear. Does this make sense to people why this works? Okay, great. All right, so I just a couple more things before we go on to control flow. So first of all, we earlier saw the type function. I believe we looked at it to see that we have type of a number like 10 is an integer, but type of a number like 10.5 is a floating point number. What this is telling you is the type of the object that you pass it. So every object, in addition to in Python, everything being an object, every object also has a type. So the type of a string is str, is what this the type of. Similarly, if we ask for the type of fruit prices, we'll see that that's a dictionary. And then finally, there's one more function I just want to mention here, and that's it's called dir, stands for directory. And what this does is it tells you all the methods that an object has. So if we ask for the dir of fruit prices, there's a whole bunch of methods here. A lot of them start with double underscores. So again, those are sort of Python internal methods, and we can mostly ignore those. But then there's a bunch of these methods like clear and copy, get. So just as an example, let's look at the get method. Fruit prices.get is a lot like fruit prices open bracket, except what we can do is we can ask for, so if I ask for blueberry, which we actually know is not in the dictionary, I can give a default value, no blueberries, which is what this will evaluate to if blueberries isn't in the dictionary or blueberry isn't in the dictionary. So that evaluates to no blueberries instead of raising a key error. Whereas if I'd said fruit prices blueberry like this, it would have raised a key error because blueberry is not in our dictionary. Similarly, if I say fruit prices dot get apple, no apples, we get 65 cents because apple is in the dictionary. So basically, the dot get is basically the same as asking for a key, except you can give it a default value. Okay, any questions so far? All right. So at this point, we're going to talk a little about control flow. So so far, we've looked at a lot of different variables and how we can store some data and how we can manipulate some of those variables, but we haven't done anything that would let us make a decision. So conditionals are and control flow are the primary ways in Python we can make decisions. And we'll just start with a very simple example. So I'll say mango equals 0.2, mango is 20 cents. And then I'm going to say if mango less than 50 cents, then I'm going to push enter, and you'll notice that Jupyter indents this next line by like 4 characters. That's because we're now in the body of this if statement. So basically anything that's indented below the if statement after this colon, anything that's indented will get run only if this is true. So what we're going to do is we're just going to print mangoes are super cheap. Get a bunch of them. All right, and then I'm going to have, I'm going to unindent, so I'm no longer in the body of the if, and I'm going to say elif. Elif is short for else if, meaning if this is false, but this next thing is true, and I'm going to say mango less than $1, we'll print get 1 mango from the store. Okay, now I'm going to de-indent again and say else. So this block will get run if none of these other blocks are true. We'll say, meh, I don't even like mangoes. Okay, so now if I run this by pushing Shift Enter, it prints out mangoes are super cheap, get a bunch of them. And that's because mangoes is 20 cents here. And so when it comes to this if statement, mango less than 50 cents evaluates to true. And because this is true, it runs this block. Oops. Well, if I can highlight it, this block. Since this was true, and this is an else if, and this is an else, it doesn't even bother to test these. It just runs this first one and it's done. Now, if we made mangoes equal to a $1.20, we would print out meh, I don't even like mangoes. And that's because this is false, so it doesn't go into here. It goes down and tests this expression. This is also false because mangoes are now $1.20. So it's going to skip that and go straight to the else expression. You don't have to have these else if and elses. You can have just an if by itself if you want. So we could just say mango equals 120, and then if mango less than 0.5. If we run this, nothing's going to happen because this is false, and so it's just going to skip over this line. But there's nothing else for it to do, so it's just going to evaluate to nothing at the end, like that. Any questions on that so far? Okay. Okay, so that's an if statement. That's one kind of control, and probably the most important part of most important kind of control flow mechanism. But there are several others. For example, a lot of times we need to do something, but we need to do it a lot of times until some condition is true or some condition is false. And for that, we need a loop. So we'll start with the for loop. For loops are the kind of most common loops in Python, I think. At least I use them most often. So recall earlier that we made this list, a list. Suppose we just want to print out every element of the list one at a time. So we can say for item in a list, and then put a colon. And then we can say print item. So what this is telling Python to do is to step through every element in our a list variable. And one at a time, each element will get assigned to the variable item. And then it will evaluate whatever is indented beneath this for statement with that item assignment made. So when we run this with Shift Enter, it's going to print out every element of the list one at a time. Okay. So let's do a slightly more interesting example now. So let's suppose we have this list that we've made, and we know it has numbers and strings in it. And so, but we want to pull apart the numbers and strings and have a list of numbers and a list of strings. So I'm going to say list of numbers, and I'm just going to make that an empty list to start with. I'm going to say list of strings, and I'm going to make that an empty list to start with. Okay, so now we're going to loop over our list using the for loop, for item in a list. Now, what I need to do next is check to see if item is a number or a string. Does anyone have an idea about how I could do that? Yeah. Very close. So we absolutely need to use the type function since we've seen that. So we could say, and remember earlier we saw that if we say type of something like ABC, it returns string, right? So we can say if type of item, because the item is the individual item, a list will always be a list. But if type of item equals str, which is the type, which is a string, then we can say list of strings dot append item. Otherwise, else list of numbers dot append item. Okay, now let's print those lists out. So I'm going to just print strings and numbers. Now, I don't think we actually looked at this or talked about this earlier, but when you call the print function, you can actually pass it multiple arguments, and it will just print them out as one line, basically. So when we run this, it prints out at the end strings, and it prints out our strings as a list, and then numbers, and it prints out our numbers as a list. Okay, any questions on that? All right, so there's actually, I just want to mention, there's another way we could have checked this. We haven't talked about it yet, but there's a function called isInstance. So rather than saying type of item equal string, we can say, is an item an instance of a string? IsInstance basically just checks whether or not an object is of a certain type. And this function becomes important later because objects can have multiple types. So something can be a string and also a special kind of string, for example. And so sometimes we might ask for the type of an object, and even though the object is a string, it's actually a special kind of string. So what it returns isn't str exactly. It's like, capital string or something like that. So this, if we get to it later, we'll talk about inheritance a little bit, and we can talk a little more about what that all means. But for now, this is just another way to check the type of an object. Okay, any questions on any of this so far, or on this block of code here? Okay. Another way we can iterate over things is what's called list comprehension. And list comprehension is sort of a compact way of doing a loop that captures the results into a list usually. So as an example, we could have done this a little differently. We could say strings only is equal to, and then we put an open square bracket like we were starting a list. And then we're going to say item for item in a list if isInstance item string. So this is a weird little way of writing a loop over these items in this list. And basically what this does is it says, okay, for item in a list, that's the iterative part. That's basically, this says Python's going to iterate through a list and assign each element to the variable item. And then back here it says if isInstance of item string. So if the item isn't a string, it's just going to go on to the next item. Otherwise, it's going to put it in the list. So when we evaluate this with Shift Enter, nothing happens because, or nothing gets printed out because we did an assignment in this this line. But if we then say strings only, whoops, I mistyped that, didn't I? We have our list of strings. Does this line make sense to everyone? This is a kind of idiosyncratic Python way of doing things, but.
I have a quick clarification. I end up with Python always struggling with this, but I have trouble with what we define as a bracket versus what you don't. For example, in the for loop that you wrote initially, you had defined these two empty brackets of list of numbers, strings, but then in the for loop you name a_list, which was not defined before. It may be a novice question, but just if you can clarify on that.
Yeah, no, that's a great question actually. So, and I probably made it a little more confusing because I defined Mango at the top of both of these, even though I didn't really need to. So, when we run these cells, the cells aren't. They're self-contained in that Python runs them as one unit, but when you run a cell, whatever results from it is part of your Python instance. And it's not like you're restarting Python every time you run a cell. So if you define a variable in one cell, it's defined until you delete it or something. So we defined, I think at the very top here, we defined a list. And because we defined it as the very first thing we ran, it's part of our Python runtime right now, and it will be until we quit Python. Does that answer your question?
Yes, I didn't recognize. I forgot that we did this. Sorry.
Yeah, sorry. I should have probably redefined that at the top of that other cell.
Thank you.
Yeah. Oh, really? No, it shouldn't time out. So if your a list variable disappeared, that probably means that your Python instance got reset somehow, or like you might have lost connection or something. That's a little weird. You can, it is possible to accidentally restart the Python kernel with keystrokes. So that might have happened. If it happens again, though, say something and we can check it out. Yeah. Oh, right. That's probably. Right. So for people on Zoom, the question is basically, when does the Python instance reset? When you open a new notebook, do you get a new Python instance? If these numbers start over at 1 because you restart the notebook or you leave Jupyter Hub or something, what does Python remember? The answer is basically that anytime you start a new Python instance, it will be fresh and clean. Like there's nothing it remembers from your past Python instances. With certain kinds of Python ways of interacting with Python, it'll remember the history of what you typed, but that's about it. Jupyter notebooks aren't quite like that. If we were using the, remember, if you open the launcher, you can open a console. And this is more of a type line by line instead of having cells. That would remember your history. But for Jupyter notebooks, not so much. But yeah, every time you restart Python, it's going to be a clean instance with nothing that it remembers. Yeah.
Sorry, could I ask for that last item for 54? Could you just clarify the order of what's happening there? Because I see a lot of items and I'm.
Yeah, totally. So these, one of the things about this way of writing iteration is that it's a little unintuitive because the order of operations is not the order it's written in. So for this kind of syntax, the first thing to pay attention to and the first thing that really gets evaluated is this part right here I've highlighted, for item and a list. So this tells you what you're iterating over. And that item is getting assigned to each element in a list. It then looks at anything after that iterator, and specifically it looks for if statements. So any if statement after that iterator will get evaluated for the item, for each item. And if this evaluates to false, it'll just go on to the next item. Otherwise, it'll put whatever is over here on the left into the list. So just as an example, we could also have put item.upper here. And because item.upper evaluates to an uppercase version of the string, this is totally fine. And then when we run this, we get the same result. It's just all in uppercase.
Okay.
Did that make sense?
Yeah.
Okay. Any other questions about any of this? All right. Okay, so let's talk. I would like to very quickly talk about importing, and then we'll talk about functions, and we'll probably pick up with functions tomorrow and then go on to NumPy. All right, so obviously we've been looking at a lot of different things we can do in Python, but a lot of things that you can do in Python have been written by other people. They're not part of the core Python language. And so a lot of times, in order to use something, we need to first import it. Import is basically a way of adding a variable to your Python instance that contains a bunch of functions and values and things that you can use from someone else or some other library. So as an example, let's go ahead and import the JSON library. So I just run import JSON. There's no output from that. But now, if we evaluate JSON, it's what's called a module, a Python module. And JSON, the JSON library, so JSON objects, JSON stands for JavaScript object notation. It's a file format for storing simple objects like lists and dictionaries, pretty much like lists and dictionaries and numbers and strings. It's a really handy file format. You use it all. I use it all the time. It's part of the BIDS file, the BIDS format, which I believe Dora is going to talk about tomorrow. And BIDS is a really important file format in neuroimaging if you haven't used it. Anyway, it's a very common file format that's very easy to read if you just open it with a text editor. So it's very handy to be able to read and write JSON files. So we're going to go ahead and, just as an example, I'm going to make a dummy dictionary. We'll just say it's A is equal to 1 and B is equal to 2, or is mapped to 2, I should say. And then we're going to say JSON dot dump s. This stands for dump string, dummy. And what this does is it gives us back the JSON representation of that particular dictionary. Now, it happens that Python and Python's dictionary syntax is pretty much identical to JSON's syntax for dictionaries. So that's why this looks almost the same. This is, if we were to store this dictionary in a JSON file, it would be stored just like this, as this string. And we got this this method from the JSON module. If we want to see what else is in the JSON module, we can use that dir function again. And there's some things here. These are actually what are called classes. They're types of objects, these ones that start with capitals. Then we have a bunch of these kind of built-in Python double underscore things. And then there's a few other things. So there's a dump and a dump s, which is for dump string. Dump will write out a file instead of writing out a string, but we're not going to do that right now. And then there's some functions here for loading JSON files as well. Yeah. If you want to, if you want to see the like the function itself for those, so my advice generally for libraries like this, like the JSON library, which is built in, would be to Google it. Google Python JSON library GitHub, and you'll find the GitHub code. There are ways to get the source code for these libraries, for these functions. However, not every function in Python has Python source code, because some of the functions are written in C, and so that doesn't always work. It's part of a there's a library called the inspect library, which you can import with inspect. If you're interested in finding that kind of stuff, like what the source code for a particular function is, there are methods in the inspect library that will let you do that. But and if you'd like an example, we can maybe do that later. But it's kind of outside the scope of today's lesson. Yeah, good question though. Any other questions? Okay. Just two more things about imports. We can import things. So for example, we don't have to import the whole module. We can import just something from it. So we can, for example, there's a module called collections, which, so dictionaries and lists, they're collections, also called containers. There are a bunch of other collections that are part of Python, but that aren't in the core Python. You have to import them from the collections library. So as an example, we can import collections, but instead of that, I want to say from collections, import default dict. So default dict is a kind of dictionary. Actually, let's, I don't think I've told you how to get help on stuff yet. So maybe we should just start by looking at the help. So to get the help, we can type question mark, and then we can say default dict. And if I push Shift Enter, it's going to print out a bunch of information about this function. So basically it says, when you call this function, it creates a dict with a default factory. Well, that's kind of an obfuscated way of saying that it's a dictionary with a default value. So if you look up a key that's not in it, instead of giving you an error, it gives you back that default value. So just as an example, let's say test dict equals default dict 10. Whoop. Oh, right. My mistake. So let's instead use int. You have to, so default dict has to be passed a function. So int happens to be a function. We used it to turn strings into numbers. But similarly, if we call int, we get back the number 0. So we're going to make a test dictionary, which is a default dictionary with the int function as the default function. And then if we look up, we know this dictionary doesn't have any keys in it yet. We haven't put anything in it. So if we ask for some key that's not in there, normally it would give us a key error. But because this is a default dictionary, instead, it calls this function and gives us that instead. So when we ask for that key that doesn't exist, it gives us back 0. And now if we look at the test dictionary, it's actually that key is in our dictionary. I don't actually use default dictionaries that often. I just wanted to demonstrate that this was something you could do here in terms of importing a specific item from a module. One other thing you can do is you can import collections, and then you can say as calls, for example. And then instead of being called collections, it's called calls. So we see here that when we evaluate calls, it's this collections module. Does that make sense to everyone? All right. So we've got just a few minutes left here. So I'm just going to introduce the concept of functions, and we'll talk a little bit more about them tomorrow before we move on and talk about NumPy. So we've seen a bunch of functions. We just saw that using the function int by itself with no arguments to produce the number 0. We've also seen things like calling int with a string of 10 in order to turn that into the number 10. In fact, we've seen all kinds of functions. Most of what we've done has involved some kind of function. So what if we want to define our own functions? Yeah, go ahead.
Quick question. So you said everything in Python is an object. Just trying to categorize correctly. So is a function considered an object as well? I don't know. Okay. Yes.
Yeah, even functions are objects. So that's not true in a lot of languages. For example, in C, C++, functions are not objects, but at least not precisely. But in Python, functions are absolutely objects.
Okay.
Yeah, and functions can even have methods, interestingly enough, but we won't talk about that today. Okay, so if we want to define our own function, what we do is we use the keyword def, and then we put the name of the function. So example function, and then we put an open parenthesis. And we put a list of any arguments the function accepts. Now, for our first function, we're just going to have a function that doesn't take any arguments. So we're just going to put a close parenthesis. And then we're going to put a colon. And then if we push enter, you notice it indents again. And that's because everything that's indented after that colon is going to be part of the function body. And as soon as we don't indent a line, then the function is over. So in this example, I'm just going to have it print this function. This message just demonstrates how functions can be called. Now I could put another line here. I could, for example, set some variable equal to 10 and then print something like that. So we'll go ahead and have this be our first function definition. When I evaluate that, it's sort of like an assignment statement where it doesn't print any output because we've assigned this example function value, this function body. And then if we run it just like any other function where we put its name and then open and close parentheses. And when we run this, it prints the messages, the first message, it sets that value to 10, and then it prints our second message. Now, part of the reason I put this sum variable in here was I wanted to demonstrate that when something gets set inside of a function, the scope in here is the function scope, and it's not the global scope. So this sum variable got set inside the function, but it didn't get set in the Python global instance generally. So if we ask for some variable, Python doesn't know what that is. That only exists inside of the function. And similarly, if we ask if some variable is in locals, The answer is false. Now, if we ran this inside of the example function after we had defined it, it would have returned true, because inside of the example functions, some variable was a local variable, but outside of it, that variable is lost. Does that make sense to everyone? Okay, any questions so far? Okay, well, we've got just a minute left, so I'm going to show an example with some arguments. And in fact, well, let's do a more interesting function here. Let's suppose we want to define a function for a Gaussian. We want to define a function for a 2D Gaussian, and so I'm going to call this this function Gaussian 2D. And for a 2D Gaussian, what we need, actually, let's not make it 2D. That's a little too complicated. Let's make it a 1D Gaussian. So we need to know the x value. At what x value are we calculating the Gaussian y value? We need to know the mean, which I'll call mu, and we need to know the standard deviation, which I'll call STD. So these are 3 arguments to this function. And I'm going to put a colon. All right. So in order to do a Gaussian, we're going to need to have an exponential function, right? We need to be able to calculate e to some value. So we're going to import something from the math library, which is the exponential function. So from math, import exp. Exp takes a single number and it returns the e to that number. Okay, does anyone remember the equation of the Gaussian offhand? I believe it is exp of minus x minus mu squared. Now you notice I put 2 stars here. 2 stars is the exponential operator. So a star star b is the same as, and here I'll make a markdown cell so we can see it. This is the same as this, right? Okay. So I'm saying minus x minus mu squared divided by actually let me do it this way. X minus mu over STD squared divided by 2. I believe that's the, please correct me if I made a mistake there, but I believe that's the exponential, the Gaussian definition. Now we've assigned this variable y here, but we want to be able to get that variable out of the function somehow. We need to get it back to the global instance. And we saw already that if we define a variable inside a function, that doesn't get it into the global Python instance. So in order to do that, we use a command called return. And what the return function or the return statement does is, as soon as Python encounters a return statement, it says, okay, I'm done with this function. I'm going to finish and go back to whoever called, and I'm going to have the function evaluate to whatever is over here on the return statement. So now that we've defined this, let's go ahead and test it. And we can say Gaussian, I'm just going to use something simple. I'm going to say, what's the Gaussian value at 0 with a mean of 0 and a standard deviation of 1? And the answer is 1, and that should be correct because Gaussians are 1 at 0. On the other hand, if we asked for what the value Gaussian value at -1 was, we're going to get this, 6.606, etc. And that's because that's the value of y when this function reaches this return statement. Okay, that makes sense to everyone? Any questions? Yeah. Oh, this. So remember yesterday we mentioned that when you have a cell highlighted but you're not inside of it, you can push the M button to turn it into a markdown cell. You can also, I think, go up to, there's a menu item, I think, that will let you do that too. But you can then do LaTeX math equations using these $signs. And A caret B is how you do an exponential in the LaTeX math equations. Yeah. Any other
I have
questions?
A quick question.
Yeah.
Why would you create a function in this case when there are no variables that are global?
Yeah, that's a good question. So global variables, it may seem intuitive that you want to access and edit global variables inside of a function, but that's generally considered bad programming style because global variables are hard to keep track of. If different functions change your global variables, it can be very hard to determine what state your global variables are in generally. So usually you want to return a value and have the function not change the global state, just do something internally and then give you a value back. And that just makes your code a little easier to kind of follow and keep track of. The reason you would want to have a function when you don't set any global variables with it is that suppose I've written another function, and this function is part of some analysis that's going to eventually write out some files. I may need to call our Gaussian function, if I can spell it right, in here, and use that Gaussian value and then write it out as part of some analysis or something. So it's not really important that everything be in the global scope. It's just important that your program be able to do whatever it's supposed to do and use these functions on the way. Does that more or less answer your question, or were you getting at something else?
Yeah, that does. Thank you.
Okay. So I believe we are out of time. I think it's time for the coffee break now. I'm happy to stick around here for a while and answer more questions if people have them, including as Zoom people. But otherwise, I'd say we can all break for coffee, and we'll be back here at 10:30 for Damien Eek's lecture.